higher derivatives. All right. Say we've got f of x equals x cubed plus 2x squared minus 7x plus 4. What's the derivative? Well, the derivative, we're back to our just regular polynomial, so it's all good. Derivative of that's 3x squared. Derivative of that would be 4x to the first, and that would be minus 7 derivative. That would be 0 derivative, so the derivative is 3x squared plus 4x minus 7. Well, we're now going to call that sometimes the first derivative, because I am now going to take a second derivative, and nicely it's just going to be another little mark there for second derivative. And nicely, the second derivative, turns out it's just the derivative of the first derivative. So if I do the derivative of my first derivative, what do I get? 6x plus 4 minus 0, 6x plus 4. That's called the second derivative. So the second derivative is just the derivative of the first derivative. And then we could keep going. Yeah, we could do a third derivative. Just be 6, yeah. Third derivative. Sure could. Just a couple other notational things for second derivative. Of course, we've got the f double prime there, sometimes referred to as, but we can also use the d, the big D. When you go to that, you use a d squared, looks like, but it's second derivative. You know, the first derivative is d f of x, so second derivative is d to the second power, it looks like. Here's another one. This one, I think, more calculus 2. You see it a little bit. Looks like d squared y over dx parentheses squared. And then we'll also sometimes use, instead of the double prime, we'll use f parentheses 2. And that comes in more with higher derivatives, fourth derivative and beyond that. But if you see f looks like parentheses 2 power, that's another derivative notation. It means the derivative, the second derivative. So anyway, I don't know that they'll have you do one, but let me just give you another example here real quick. Yeah, all right, so we got y equals x to the 6th. What's y prime? 6x to the 5th. What's y double prime? The derivative of 6x to the 5th, 30x to the 4th. Y triple prime? Well, it's the derivative of 30x to the 4th. 120x to the 3rd. Yeah, and usually that's kind of where we stop with the little hash marks or whatever you want to call them. Then we go to the parentheses stuff for the next derivative. The fourth derivative, usually you would see it with parentheses 4. And it's just the derivative of that would be 360x squared. Fifth derivative, you get the point. This one could go a long ways. We'd eventually run out. Eventually we get to 0 on that one, won't you? But just wanted FYI there. Okay? All right. Okay. Let me show you another one here. Let me see.
All derivatives eventually go to zero, and derivatives of the slope of your tangent. What's that saying graphically?
Well, yeah, eventually go to zero. Yeah, you know, this is a line. That's a straight line, and so that's, yeah, you'll go to a horizontal line, and then the horizontal line that goes to zero. Yeah, anytime you have a horizontal line, the derivative is zero. The slope is zero, so the derivative is zero. I was debating on what to show you next. Let me just go ahead and get you started anyway. Yeah, let's talk about this. All right, so what we wanted to explore next are applications of derivatives. Of course, we've already done one application. One application is find the equation of the tangent line to y equals 1/2 x cubed minus 3x at the point 2, negative 2. Treat that as an application, okay? Find the equation of the tangent line to y equals 1/2 x cubed minus 3x at the point 2, negative 2. Call it an application because you kind of have to think about what this is asking for. We've done these previously. Just now they're a whole lot easier because what do I need to get here first? Well, the equation of the tangent line is going to be, first of all, it's a line, so we need the slope of the line. And we now know, we've seen it several times now, the slope of the tangent line is equivalent to what? The derivative, right? The slope of the tangent line is the derivative at whatever point you're talking about. So this is another derivative problem. I need to find the derivative. Derivative of that thing is, what would it be, 1/2 times 3x squared minus 3. So it's just a whole lot easier to get the derivative now. Instead of having to go through the limit as h approaches 0, f of x plus h, all that good stuff, we could just go with the rules. We can just go to the answer here, basically. So that makes it, what, 3/2 x squared minus 3? Now, in this case, I want specifically, though, a specific slope. I want the slope at 2, negative 2. So what does that mean for my derivative? Well, isn't this at the x value of 2? So my slope, then, is going to be, at 2, negative 2, is going to be the derivative, plug in the x value. And the x value here is 2, so I'm just going to plug in the 2. So it's 3/2 times 4 minus 3. Hey, that works out nicely. It's 6 minus 3, so that's 3. But that's still not quite the end because the question was find the equation of the tangent line. Now I have the slope of the tangent line. What's the equation then of the tangent line? Well, different ways to do it. If you want to do it this way. So the equation of the tangent line you just want to y equals mx plus b. I now know the slope is 3. and figure out b however you want to. I'm going to plug in x and y to be 2, -2. Y is -2. X is +2. So b is going to be, what? -2 minus 6, -8. So the equation of the tangent line is 3x minus 8, since b is -8. So if we were to graph 1/2 x cubed minus 3x and graph 3x minus 8, we should see it running tangent at 2, -2. So that they'll probably ask you to do that, graph both of them, and see that you got it. Pretty accurate. Okay? Got one more quick example for you. Is that okay? Did I get too much of it? Oh, let's see. I had y equals 3x plus b. -2 equals 3 times 2 plus b. Okay, there you go. Does that help you? Yeah. Okay. Right. Let me give you one more of these. All right, so find the slope of the tangent line. And then we could do the same thing, find the equation, but let's just find the slope of the tangent line to y equals 3x to the 4th over 2x minus 1 at 1, 3. Find the slope of the tangent to y equals 3x to the 4th over 2x minus 1. Okay? How would I do that? Same way, right? The slope of the tangent is equal to the derivative. So I need to find my derivative. How am I going to find the derivative of that? Well, we talked about the product rule and the quotient rule. Those don't go away just because we're not talking about them anymore. They come up a lot. How do I find the derivative here? I've got to use what? Quotient rule. Yeah, because I got a quotient, a fraction. Something divided by something else. That's a quotient. How does the quotient rule work? Low d high minus high d low over low squared. All right, so low, 2x minus 1, times d of the high, derivative of the high, 12x cubed, minus high, 3x to the 4th, times d of the low. What's d of the low? Derivative of the low one? Just 2, isn't it? Over low squared. Clean it up a little bit. Multiply that in. That would be 24x to the 4th minus 12x to the 3rd minus 6x to the 4th over 2x minus 1 squared. And there is like terms there, so that would be what, 18x to the 4th? These two terms combined. 18x to the 4th minus 12x squared, 12x cubed over 2x minus 1 squared is the derivative, but I want the slope at 1, 3. So the slope at 1, 3, well, that's going to be your derivative. Just plug in your x value. Here's your x value, isn't it? So I'm just going to plug in x to be, oh, that's nice, x is 1. Okay, so 12 times 1 to the 4th minus 12 times 1 to the 3rd over 2 times 1 minus 1 squared. It's really nice because 1 to the 4th is 1. So it'll be 12. Whoops, that's supposed to be 18, isn't it? 18 times 1 to the 4th. I don't know where I got 12. I guess I looked over there. So it's 18 times 1 to the 4th plus minus 12 times 1 to the 3rd. So it'll be 18 minus 12 over 2 minus 1. Oh, that's even really nice. Over 1 squared. It's 6 over 1, which is 6. Slope of the tangent at 1, 3, 6.